Hello, everyone, and welcome to our webinar, Google Gemini Preview and Hands-On with Vertex AI. My name is Matt Brown. I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you're currently in a listen-only mode. You can submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a single store webinar, heads up that we present regular webinars demoing data and AI use cases and new technologies. In fact, if you like today's topic, heads up that on Monday, we will be presenting Beginner's Guide to LangChain, chat with your multi-model data. We get lots of questions about various models like Bedrock, OpenAI, Llama, and others, pros and cons of using individually or simultaneously together. So come join us next week to see Akmal on our team show how LangChain can be used to achieve all this, including a live demo showing geospatial and time series data that's accessible from inside Single Store DB. So if that sounds interesting to you, you can RSVP right now. There's a bit.ly link on your screen, bit.ly Beginner's Guide to LangChain. I will put that link in the chat in a bit. You can also take a photo or a screenshot of that QR code that's on your screen, and I hope to see you on Monday. Okay, back to today's topic. We have fantastic technical experts joining our Zoom. Madhukar is online, ready to answer your questions interactively. We will try to get to as many as they come in. We do have a large audience today, so if we don't get to everything, we will email you responses. We will also be flagging some of the more popular questions for the live Q&A at the end of the session. And we'd love for you to try out the technology that we'll be talking about today. Anyone who tries it today will be entered for a chance to win brand new AirPods Pros, the newest version, I have confirmed. So all you need to do to participate in that raffle is visit this link on your screen. It's the bit.ly Gemini Vertex webinar raffle, or you can scan the QR code that's on your screen. I'll put this link in the chat in a few minutes. Or you can get there even faster if you just take a photo or screenshot of that QR code. All you need to do in order to participate is log into the link. You can do a free trial if you're a new user, or you can log into an existing account if you are already a customer or an ongoing trial of Single Store. We will be checking the folks who log into this link, and we will announce a winner by the end of today's session. So let me introduce our primary speakers today. Once again, I mentioned my name is Matt Brown. I'm the head of global growth at Single Store DB. I have the pleasure of organizing these weekly webinars on AI that show the world what's possible, the general purpose database that has vector capabilities. We have upcoming webinars on LangChain, Alexa, Llama Index, and much more. So you can subscribe to our webinars to stay up to date on those. And then, of course, we have the real star of our show, Alex Peng. Alex's formal training and education have been at Stanford's computer science program. I've had the pleasure of having him aboard as a growth engineer at Single Store. You might recognize him from some of our past webinars on data and AI applications, and we are thrilled to have him back today to walk us through the Vertex demo. So let's get started with a little overview of what Google announced this week. And then after that, we will get into Alex's hands-on live demo and code share. So it's been a very exciting 48 hours in the AI wars. On Wednesday, Google announced the launch of its largest and most powerful AI model, Gemini 1.0. There's some very exciting aspects of this launch, along with some sizable caveats and some controversies that have unfolded in the time since the announcement. So the first thing to know about Gemini is that they designed it for multimodality, reasoning across text, images, video, audio, and code. So how is this different from ChatGPT-4, you might ask? Well, according to Google's own benchmark tests, Gemini Ultra specifically can outperform GPT-4 on nearly every metric that they tested it on. You can see on this slide better scores versus GPT-4 and expert humans on math, physics, history, law, medicine, coding, and more. And a lot of the promo clips that have been released indeed show that. We will get to those in a minute. Google also says that Ultra is remarkable in its ability to extract insights from hundreds of thousands of documents through reading, filtering, and understanding information, which will help deliver breakthroughs at digital speeds in many fields from science to finance. For me, this is a big claim, and if true, it's really exciting because personally, I'm very obsessed with ChatGPT 4, but my experience has also been that I need to spoon feed it a little bit. I need to give it the right size chunks of information. I need to help it troubleshoot a little bit. I need to do some trial and error with prompting. I need to think about what data I'm giving it and how that data is organized or formatted. And only by manually navigating those aspects have I found GPT-4 to be so impressive. It's a labor of love that I'm willing to do given the results, but the idea that that labor could be disappearing with Gemini Ultra is very exciting to me. You'll notice that I'm talking a lot about Google's claims here, and that's because the vast majority of these exciting new announcements haven't actually been released yet. That will make more sense if you see this slide that shows that Gemini comes in 3 sizes. Ultra is the most advanced. It's the one behind the most exciting demo videos we've seen this week. You maybe have seen like the blue duck video or some of the magic tricks. This is the one that's supposedly outperformed GPT-4 across all of those benchmarks, but it hasn't been released yet. Google says that this will become available to developers on December 13th, just a few days from now. So it's good to learn about now. And then will be available to the public in a version of Bard Advanced, which will be available sometime next year or early next year. Been a lot of speculation about what Bard Advanced will look like since it hasn't been formally released or previewed. Most people think that it will resemble ChatGPT Plus. So you can get ChatGPT for free, but then you can also pay $20 a month to get ChatGPT Plus. Most people are thinking that there's going to be a similar model for Bard, which is free, but Bard Advanced is subscription. That's just speculation, but I think it's probably accurate. On the other hand, Gemini Pro here in the middle is the version that's available right now. You can play with it for free inside the regular Bard interface. I played with it, but the claims about it are a bit less exciting. So, they say that it beats out GPT 3.5 across 6 out of 8 benchmark tests, but 3.5 was released, many months ago. It's not GPT-4. Google released this video of Mark Rober playing with it. I've played with it too. There's some cool aspects to it. It's also available in English in 170 countries. Will be more languages and more places like Europe soon. But again, this is pretty familiar with folks who have played with other models, OpenAI and others over the past several months. Now, Nano, the smallest size of Gemini, which is designed for efficient on-device tasks, is kind of interesting to me. They showed off some interesting capabilities here, like the summarize button. This is a way you're on your phone, you can click a button to get a summary of recorded conversations, interviews, etc., all without a network connection, which is pretty cool. They also showed a new smart reply. Now, this is only available in developer preview for US English in WhatsApp. But you can imagine the possibilities there. To me, it kind of feels like the Gmail suggested replies, but maybe more intelligent, more contextually or conversationally aware, and then maybe more widely available in smartphone apps, which is kind of a cool future to think about. And then the call screening feature is also kind of cool. This is basically Google Assistant replying to unknown calls to get more information without you having to answer the phone. So they show this example where there's a text sent out. It says, "Hi, I'm Google Assistant. Can you say what you're calling about?" And the person responds, "I'm just calling to confirm your appointment." So I think what's really drawn the most attention this week has been the Gemini Ultra size that people are really excited about. Again, currently unavailable, but this is the one that will be available on December 13th to developers and then available to everyone via Bard Advanced subscription, likely sometime early next year. So you've probably seen at least one of these videos online. They're all very cool. You maybe saw there's some spatial reasoning videos. These are puzzles. So, the user asks Gemini, are these planets in the correct order? Gemini responds, no, Earth comes before Saturn in the solar system. There's some multimodality features that are really impressive. So you can see up here, there's a video where they quiz Gemini on this video and series of images saying, what movie is this? Gemini says, that looks like bullet time from The Matrix. Another that impressed me a lot was the magic trick videos. This is where the user walks through some sleight of hand tricks with like a coin disappearing and a ball cup game. And even though the trick isn't explicitly shown or revealed to Gemini, Gemini is able to intimate what's happening, can understand that this is a magic trick that's happening, and then even make a strong guess as to how that trick is accomplished. And then there's the tools videos. You can see that here. These are where Google shows off Gemini's new multimodal input and output capabilities. So in this video, the user says, can you tell me what are these instruments? Can you tell me a song based on these instruments? What if I added a palm tree? And Google can, ascertain what's going on in those images and then come back with a song and then come back with, a tropical song. So this shows that it can reason on hand-drawn image inputs and retrieve external outputs. And then the final thing that they showed off is the game video.
Hey, Monica, is
Worth
Matt
noting.
frozen for you? Oh,
Can you hear me
Yeah,
now?
you
yeah,
froze for like 10 seconds.
Okay, sorry. Is my connection better now, Alex?
Yeah, you're all good.
Image creation video clips were very impressive to me. I think up there with the best that I've seen for Dolly, Stable Diffusion, and Copilot. So all very impressive, but I'd be worried.
Matt, it looks like your connection's a little unstable. Ooh.
Any better?
Yes. Why don't you
Okay.
try for another like 15 seconds or so? But I can take over too if it keeps dropping.
Okay, I'll turn it over to you if this is any laggy. But basically, I wanted to close out here saying that there has been some controversy associated with these videos. Yesterday, TechCrunch released an article saying that some of these videos were faked. They said these were carefully tuned prompts. They were still images. They were kind of shortened in the videos to make them seem very seamless or real time. So there is a lot of controversy, and I think that controversy won't be settled really until December 13th, when we can really get our hands on and see what these things can do in real time. With that in mind, obviously now is the time to start preparing to get hands on. Google AI Studio, Vertex. So I think this is a perfect transition to hand things over to Alex to kind of show us hands-on to learn more about these new tools and technologies that are available.
Sure. Thanks, Matt, for the preview of Google Gemini. Yeah, I hope everybody's as excited as I am for some of the new capabilities that are getting released through Google Gemini. Something that really stands out to me about Gemini that I think really marks an exciting new era in the future of these like foundation models is how Gemini was trained from the ground up to be multimodal. So some of you may have tried, like for example, these like avatar generators that are like ChatGPT apps. Well, they kind of rely, something that the Gemini technical paper points out, which is really exciting to me, is that they kind of rely on this intermediate natural language description of what's going on that gets fed into a text-only foundation model, or gets outputted from a text-only foundation model that then gets fed into an image generation model. But Gemini is different. It kind of fuses all of these models into one, and so it's able to understand, at least hopefully, none of us have access to the API yet. It's able to understand at a much deeper level than before. So with that being said, I wanted to just give a preface for what the demo is gonna look like. Basically, we want to get you up to speed and ready to go as soon as the Gemini API comes out. To our understanding, the Gemini API is going to be available not just through Bard, but also through Google Vertex AI, which is Google's kind of in-house, AI as an API service. So just to start off, with any AI application, especially if you're using RAG, if you're, for example, chatting with text, image, and video, which is a capability that Gemini unlocks, you're going to need a database to store all of your information that's getting fed into your foundation model. And so we're single store. We're going to, pub single store, but you have a variety of different options. We think that single store is the best option because it has not just relational SQL capabilities, so your typical SQL query capabilities, which are blazing fast, but also we have vector and hybrid search capabilities. Actually, I think we just rolled out some new vector search capabilities at our conference last month. So single store really kind of marries the best of existing relational databases and new vector databases into one database. And that way you're not kind of sharding your data out across different kind of specialty databases. So if you want to sign up for single store, what you want to do is first go to this link, singlestore.com/cloud trial. You're going to want to sign up for single store. You can get $600 in free credits. You can deploy either self-managed, kind of on your own hardware, or you can deploy on AWS, GCP, or Azure. So, if you wanted to keep everything within the Google ecosystem, you totally could do that. You could just spin up a workspace on GCP. And you can see more details about single store on the website. I won't go too much further into that here. Okay. So once you're in single store, you obviously need to spin up a workspace. And so I have one already started here. But from the console, you're going to want to add a new workspace. You're going to just add new group, just on this left sidebar here. And then, depending on your cloud provider, you'll select that, depending on your region. And then once you spin that up, you can create your first workspace, which has, a set amount of compute and memory, depending on your kind of throughput needs. And then you're also going to set up a database, which you're going to connect to that workspace. This workspace has quite a few databases connected to it, but we're going to be using this one, Vertex. And then once you have a workspace spun up with a database connected, you're going to actually want to go to this connect drop down here, connect directly. And this is where we're actually going to get the details to connect to the database in code. So let's see here. Python MySQL connector. Okay. So actually, the first time you open up this connect directly pop-up here, you'll actually get your database password. You'll want to save that somewhere safe. But here I already have the database password saved. And it'll just remind you of, what your host is, what your username is, and you'll want to save all of this because you'll see later in the demo, you'll need all of these details to connect to your single store database and start populating it. So let's move over to the Vertex console. All right, let's move over to the Vertex console. And it's going to look like this. So from the Google Cloud console, I'm just going to go back a little bit because I realize I might have skipped a few steps. from the Google Cloud Console, you're obviously going to want to log in. I have to single sign on. Okay. And you're going to want to search for Vertex AI. And this is going to be, again, that offering from Google, which gives access to some of these foundation models, vision models, speech models over API. And so once you set up your first project, you'll get a project ID, which is very important. You'll want to save that. And let's see, once you have all of that, once you have your project ID from your Vertex AI console, when Gemini gets released, it'll get put in this model garden section here. For now, it's not yet out. So you only have access to the Palm 2 model. We're going to be working with the Palm 2 model today, but because all of these models are essentially just an argument in a in a function call, once you get access to the Gemini model, you can switch it out in one line of code. And so all of these things that we're learning today can be applied as soon as Gemini comes out, and you'll be ready to hit the ground running. So let's go into the notebook here. And the notebook, I believe, will be shared out. The notebook, I believe, will be shared out as a link. But anyway, once you're kind of ready to hit the ground running, you're going to want to obviously install all of these Google Cloud and Google Cloud AI platform like packages, the single store package. We'll be working with the LangChain LLM framework library today, but these kind of concepts and models are also available, I believe, obviously directly over API from Google, and I believe just through a bunch of other library providers. But LangChain is the most popular. We're going to be using that today. So once you install all of these packages, I'm not going to go through the whole process of installing that. You will need to authorize with Google Cloud. So that you run that. That gives you a link. That gives you a link to log in with. Click allow, copy the code. And it's a unique code every time that you want to run this. And so you'll need to do that each time. Then you're able to, this is where your project ID from your Vertex console comes in. You'll need to set those credentials so that you're able to access the Vertex AI LLMs and embedding models. And here we're also going to be using, oops, I do need to run this in the background. Here we're also going to be using the LangChain integration with single store, which makes it really easy to use single store over LangChain as long as you have those details, those connection details from your single store console that I mentioned earlier. So we'll give this a second to install. And this is completely live. So hopefully everyone can see that all these capabilities are available today. And, as soon as if you follow these steps right, as soon as the Gemini API access is kind of open to the general public, you'll be able to immediately start building with Gemini. So looks like we have all the packages installed here. So we'll just be showing a pretty simple RAG demo, a retrieval augmented generation demo with Vertex AI and single store. And so what RAG means for people that are unfamiliar is essentially we're going to feed the LLM information that it didn't understand or didn't learn during training. So for example, we're going to be looking at trying to give the LLM understanding of what Google Cloud Vertex AI actually is. Because when, for example, GPT-4 was trained or Palm 2 was trained, these generative AI, companies and applications were not yet, receiving the buzz that they were. And so if you, for example, ask like ChatGPT, what is generative AI, it'll give you, kind of a waffly, like very high level answer that doesn't really demonstrate an understanding of the AI landscape as we understand it today in December of 2023. And so RAG allows us to essentially update the LLM with information that it didn't learn during training. So this is the page that we're going to try to input to the Palm 2 model. The Palm 2 model, I believe, has a more limited context window than, for example, GPT-4. GPT-4 has a really big context window now, like something like 128,000 tokens, or something like 75,000 words. The Palm 2 model, much more limited. And so RAG is actually really important because we don't have that many tokens to work with. You'll see this is a pretty lengthy page, probably something that, if we just pasted this page in, maybe we'd be able to get, a coherent response. But how about when we try to scale up to the entire set of Vertex AI docs that we can't stuff into the entire context window? And that's what makes RAG necessary. So anyway, back to the demo. We're going to be using the Vertex AI LLM, which by default is the Palm 2 large language model. So we'll be using Google's large language model today. Once Gemini comes out, it'll be as simple as, changing an argument in this Vertex AI function call to use the new, Gemini Pro or Gemini Ultra models. So we'll also be using this LangChain document loader to load that web page that we were just talking about before. And then another really important step in RAG is actually splitting up your document and chunking it so that your embedding model is able to kind of parse out a single kind of meaning or concept from each chunk. And so when you actually go back to the embedding model to retrieve the most relevant chunks for your query, you're able to get kind of a more fine-grained set of chunks. And that allows the LLM to be more accurate in its response when you're querying it. So I already have a single store database set up here. Actually, this actually is going to re-ingest all the code. I've actually already ingested all of this documentation into a single store database. And so, if you are starting afresh and you are trying to use some documentation that isn't covered in this demo, then you're going to need to ingest. You're going to need to run these two lines of code to populate your single store database. But I'll just show everybody. We already have in Vertex a table. So what the single store integration with LangChain does is when you run this code from documents method on the single store database vector store, it'll actually construct programmatically and construct and populate a SQL table for you inside of your single store account. And so I've already created this one called test. And what it does is it creates these three columns: content, vector, and metadata. You can obviously change the table name. You can change the column names to whatever you'd like. And you'll see that the text is chunked. We also have a vector, which I'll explain in a little bit. And you also get metadata. So, you get the URL associated with the chunk and some other metadata as well, which you can familiarize yourself with in the single store database, vector store documentation, and LangChain. But more on that vector piece. The vector is essentially what gives, or essentially a numerical representation of the kind of semantic meaning that's embedded inside of the content. So in more plain language, when we chunk the documentation into these, sentence level or paragraph level chunks, we run each chunk through an embedding model, which gives us basically a list of numbers that tells us, or tells the embedding model later, oh, what does this chunk actually mean? And that's important because when we use this QA chain, the QA chain is essentially an abstraction in LangChain, which takes a question, also takes an LLM and a retriever, which we're using single store here. And then it takes your question, it embeds it. So it turns your question into a list of numbers that represents its meaning. And then it uses that list of numbers to find the most relevant documents that would answer your question. So for example, if we ask, the Palm 2 model, what is Vertex AI? It's now able to understand that it provides, Vertex AI is a machine learning platform, blah, 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 blah. And that wasn't in its training data, right? Generative AI Studio, that wasn't in its training data. Oops. No. It's a little off right now, but when you use retrieval augmented generation, you can often run into these hallucination or embedding errors. But the kind of main takeaway is that with single store, with the Vertex library and LangChain, and using these kind of higher level abstractions, you can really hit the ground running as soon as Gemini comes out, and give it access to information that it wasn't able to access during training. When Gemini comes out, it'll obviously be trained on a more up-to-date, data set than Palm 2 or GPT-4. But, the minute that it comes out, it's already running behind in terms of what it can understand. There's new information, new developments coming out every single day, especially in AI. For, those of you that are AI developers, I'm sure you'll understand this very well. And so generative AI or retrieval augmented generation continues to be necessary, even in the age of multimodality. So anyway, these are just some additional queries. Obviously, if the Palm 2 model doesn't understand some of these questions without RAG, you really do need RAG to be able to get coherent responses. And this isn't just for AI development applications. This applies across any number of domains that you can think of. I saw someone in the questions was asking about like medical applications. The medical field is actually a great kind of example where RAG is critical, really crucial, because when these large language models are trained, obviously the kind of machine learning engineers that train these models take serious steps to make sure that private health information isn't included in the training set, right? But oftentimes you do want to work with an LLM and with some sort of private data, whether that's health data, whether that's like proprietary enterprise data. And so RAG kind of allows you to fuse these two kind of concepts together. You're able to use top of the line, foundation models with your own data. Another kind of side tangent, single store actually provides, really great security features for kind of row by row access to your data. And so that's another benefit of using, a combined vector and relational database. You're able to kind of enforce one unified security data access policy over your data. And so, for example, if you're trying to do RAG, you can, limit access to what sorts of information you can actually query over. So that's the demo. Happy to answer any questions. I'm sure there's a bunch of questions.
There are indeed. I will, just remind folks that you can participate in the live Q&A. I think Alex will be here as well as Madhukar. And we will try to answer as many as we can. There's a Q&A button at the bottom. And if we don't get to your question, we will try to answer you via email after the show. Madhukar, I know you've been active in the Q&A thus far. Is there any questions that you've seen in there, either outstanding questions or something you've already answered that you'd love to get to first?
Let me just jump in really quickly here, because there was that hiccup in the demo. This is great because you'll get to see some live debugging. I just looked back at the code. You'll notice that I populated this table called test, but when I kind of populated the table, but I forgot to add that as an argument here. So if I add it as an argument, it's gonna be really embarrassing if it doesn't work. It should work. So let's go ahead and try that again. Oh. So let's do this. Oh, and I also, really important, you also need to not comment out your single store environment variable. So just give that a second. Let's see. Still not working. I will keep looking at this in the background, but go ahead, Matt.
All good. Madhukar, do you see any questions that are either unopened or something that you saw that you'd love the community to hear?
Yeah, I think based on a couple of or a few questions that came in, let me just try and put this into one chunk, so to speak, and cover a few things. So first and foremost, what is so different about Gemini, right? We've seen GPT-4, and the real rumor has been that GPT-4 is not just one model, it's several models working together. And it's especially true when it comes to multimodal, or multimodal. Multimodal is where your model is trained not just on text, and there is another model that's trained on audio, another model that's trained on video. So GPT-4, in order to become a multimodal, is actually very smart engineering when it moves around and brings data from different places. That's why there was a different plugin, one for DALL-E, another plugin for audio, and so on. But they brought it together in GPT-4 in the November release. The thing that's different about Gemini is that it's trained on all three data in one place. So that reduces the latency, which means it's supposed to be a lot better. Now, having said that, they have, as we saw, there are three different models: the Nano, the Pro, and the Ultra. We haven't seen the Ultra yet. The Pro, that's the second question that came up quite a bit, is how do I try it out? It's part of Bard. So think of Bard as ChatGPT and Gemini as GPT-4. So Bard is the chatbot application and Gemini is the model. And there are several different versions of the model. The third thing that I would add is because it is multi-model or multimodal, it is now even more important to do retrieval augmented generation that is based on multiple different kinds of data. So typically what happens is when you store your data, vectors are mostly used for unstructured data. So the way a vector works is, or the way a semantic search works is that you take any object, let's say the cat jumped over the lazy dog or something like that, that gets converted into a series of numbers or vectors. And this is just like matrix multiplication. So you have these floats or numbers recorded, and think of them as almost a latitude and longitude of that data in a vector space, which is embedded, which is why it's called embeddings. Now, typically what would happen is if you use, let's say, something like vector-only database or a library, then you only store the vectors and the metadata is stores where the file of that data is. So if it was a video, then maybe frame by frame, you would convert it into vector and you store the location of those frames and videos in the metadata. So when you're doing retrieval augmented, you're doing one call to get that vector space by doing a match and a semantic search or dot product. Then you look at the metadata, then you come back, and then with that metadata, then you go back to the original source and then retrieve that other file and then send it to the LLM. So one thing to note is single store is a multi-model database in the sense it can store SQL, it can store JSON, it is compatible with the Mongo APIs, it can store geospatial, it can store key value, it can store binary, and it, of course, vector is stored as binary as well. So the reason why it's important is if you are truly building the video that Google got into trouble with, you need to curate all of that data, audio and video, in split milliseconds. So you cannot go to 5 different databases and 5 different calls in order to do that. And that's where single store with its real time and millisecond response time across multiple different data types becomes really, really important. The last thing I would say is what Alex covered. So think about Vertex AI as a place which has multiple different models. Today there's Bison. Next week there will be Gemini. And in the future there would be something else. Now what you can do in there is, and feel free to show that, Alex, that when you go to Vertex AI, what is pretty neat about it is you can go pick a model and you can fine tune it. And when you fine tune it, you get your own URL for that model API. And fine tuning is not very hard if you believe it. Basically, a fine tuning is taking a bunch of queries and responses and then telling the model that, hey, this is the kind of response I'm expecting. Can you please take all your training and then respond in a certain way? So you're not giving it more knowledge, you're giving it a behavioral attribute. You're saying this is how you would do it. And so keep that in mind, right? But the thing about fine tuning is every time you get a new model, you would have to fine tune it again. And there are 2 kinds of fine tuning, which is where I think Vertex AI excels a little bit. Is there is the supervised fine tuning, where you upload a bunch of CSV or JSON file, and it has the queries and the responses, and then based on that, it gets trained. And the latest one that they just added is called RLHF, or reinforcement learning with human feedback. So when it comes back, you have to then say that it's actually good or not. So let me,
actually just got a really good question in the chat, and maybe this will show, third time's the charm. I got a question: why use retrieval augmented generation instead of fine tuning? So retrieval augmented generation, just to remind everybody, and just to show that this works, is basically in the background. It's going to, so now it works. Basically, I just got it to work by re-ingesting. It's basically going into your context database and retrieving information that the LM didn't understand during training. When you're fine-tuning a model, that's a little different. Fine-tuning is essentially shaping the model's behavior so that it responds in a certain way. And this can oftentimes include, in the fine-tuning process, this can oftentimes include private information, but you can think of fine-tuning and retrieval augmented generation as almost working together in concert, because this is actually pretty new research that's coming out. What we're finding out is when you fine-tune, like you might think, okay, well, I want my LLM to understand, for example, the Vertex AI documentation. So obviously, I'll just have, a fine-tuning data set of all the questions that someone could answer or someone could ask about the Vertex AI documentation. and then all of the, factual answers about, the Vertex AI docs. But what we find is that when you try to feed these, like force feed these facts into the fine-tuning data set, the LLM actually tends to hallucinate, because what you're actually teaching it is, give an answer, give a factual sounding answer to every single question that a user asks. So fine-tuning is actually much more useful for, for example, if you're developing a customer support chatbot, if you want the chatbot to make sure to be nice and to ask follow-up questions, that's actually a great use of fine-tuning. You'll just include in the fine-tuning data set, maybe some, questions or some kind of prompts or user queries where, the user is kind of upset, there's a bug or something, and the chatbot responds, in a nice way, and then also asks follow-up questions. That's a great way to use fine-tuning. And then in concert, you're going to use, retrieval augmented generation to actually retrieve the factual content that you would like the LLM to use in its answer. And so hopefully that gives a bit of color to what, when to use retrieval augmented generation, when to use fine-tuning, because that actually is a really important distinction to make.
Good stuff. Madhukar, anything else I know you've been active in that Q&A. Anything else? I can grab some of these that I'm interested in, but before I do, any interest in answering one of the questions that you saw?
Yeah, so before I answer a specific question, a couple of other things too I wanted to call out. So what Alex is showing is Google Colab, right, which is where you can run a Python notebook. And there are a couple of places where you can go and download and start with existing notebooks. And you can either run it in Google Colab, which will cost you a little bit of money, or there's a free version as well, or you can run it directly inside of Single Store. So, and maybe Alex, if you want to show that, then there are a couple of places you can go to. You go to singlestore.com/spaces, SPACES. Yeah. So you would see here that we have a bunch of existing, notebooks that you can just click on and then look at the code, or you say try it now and it'll go work directly inside of Single Store. Here we will also add the one that Alex was just showing. But till we add that, there is a GitHub repository called Single Store Labs with a hyphen. So if you go to github.com and then Single Store -labs and webinar code examples, yeah, that's it. So a bunch of these we will also go put into Spaces as well. And there's the Google one is over here as well, Alex. I believe you're going to make some changes to it, but this one should work as well, correct? Good. Unmute.
Yeah, so just the little bug that we ran into was essentially remembering to ingest before querying. So RAG doesn't work unless you actually populate the database before you query it. So so this line here is the one that ingests, and then once you've chunked, embedded, and ingested all your data into Single Store, then you'll see that your QA works with RAG.
Yep, perfect. Yeah, and then there are a couple of other questions. Can I train LLM model on personal data, and can I use it for answering on my own question? Yes, 100%. I would say there are some existing tools out there that you can go try it out, or you can try out an example. If you use one of the examples that we have in Spaces, I believe we had written like a very simple RAG-based example. You can just go upload your data into Single Store and then Q&A it. So that's one way to do it. Do you need to launch an instance with the LLM in Vertex, or is it serverless? Alex, do you want to take that before I take a sip of water?
Yeah, so actually my understanding is that as long as you have the project ID, you can access the Vertex LLMs. I think you can you can, I don't believe it's serverless. You end up running, you end up running a model and make it available for inference on a Google server somewhere. So whether that's, the Palm 2, one of their foundation models, or your own custom trained or fine-tuned model.
Awesome. Madhukar, I've seen some questions about pricing, and also, are you available on cloud versus on premise? And I've tried to answer them as they come in, but I wonder if you could do just a quick overview for folks trying to understand what single store is.
Yeah, so think of single store as it's just like MySQL. So you would have row-based tables, and it's many way also like Snowflake, because you can store petabytes of data and you can run analytics on the same table, on the same database, but it's not a batch data warehouse, it's a real time. So effectively, it's a SQL, distributed SQL. And unlike a classic, OLTP or transaction only database like Mongo, or a data warehouse like Snowflake or Databricks or whatever, the two is in one place. So that's number one to understand. So if you know SQL, if you know MySQL, it's the exact same thing, no learning curve. Two, you can run it either as a Docker instance if you're trying to do it locally. You can do it in cloud, which is what Alex showed, or you can run it as hybrid. So we have customers who are doing it hybrid, which is both cloud as well as on-prem. And fourth, you can also run it as managed service. Managed services, you just take the database and you run it as a Kubernetes cluster. We have an operator for that into your own VPC, your choice of cloud as well. So that's kind of the high level of the database, as well as how do you deploy it.
There's also a follow-up question, Madhukar, about how do you compare single store to Elasticsearch or ChromaDB? And so I wonder if you want to talk at all about like pros and cons, vector specialty database versus single store. You want to talk about that at all?
Yeah, absolutely. And in all openness, I used to work for Redis as well. And Redis is primarily used for caching and in-memory database. But think of Redis as primarily key value. And you can persist that data, but it's memory first. The thing that's different about single store is it has a 3-tier architecture. So when you create a table, it actually creates a row-based table in memory, which is why it's extremely fast. And since it's in memory, when you do a commit, the commit is like super quick. So for transactions or for data ingest, which is through a pipeline, which is one of the features in single store, the reason why it's different is you can bring in a Kafka stream and you can query the data while it's coming in. We're talking about millions and billions of data events in a few milliseconds. Number two is that, like I said, it's both SQL, multiple data types, except for graph. It's not a graph database. If you're looking for a graph database, then that's something else. And if you are using this for real-time analytics, then of course, what happens is in that architecture, it goes from when you store a data, unless you specify to only say columnar, it stores that data both in row-based and columnar-based. So columnar-based is when you have aggregates, you do sums and other stuff, which typically is a different storage. The reason why we changed our name from MSQL to single store is because it's single store, like single storage. And then so it goes from in-memory to your local disk, SSDs, and NVMEs. And then it finally goes into object storage. So Google Bucket, or it goes into AWS S3, and it supports both Parquet file, CSV file, and so on. And the compute and the storage is different. So if the question is, how is it different from pick any one? You might find a few data types only in some other database, or it's either only in memory, but for when it goes to the data storage, you kind of persist it, but it doesn't have a 3-tier architecture. It's either analytics or it's all vector only. So what were some of the examples, Matt, that you gave?
There was
Superbase.
Elasticsearch, there was ChromaDB.
Yeah. So Elasticsearch, as the name suggests, is primarily for search. They do both. They started off with Lucene, which was primarily exact keyword. Now they've added vectors. The way they do vectors is different because they use something called an ELSER LLM in their own model for doing it. But the data storage is different. It's multiple data types and real time and all that. It's more of a search versus a database that you would use for either transaction or analytics. But a lot of people do use it for a lot of regular database use cases as well. Then Superbase, I believe, is the open source version of Firebase. It's primarily for doing authentication, but your backend as well. You expose your database directly as an API. But again, similar things. Is it analytics based, or is it both analytics and transaction? Depending on your use cases, you would have to pick and choose. We kind of been around for 10, 12 years. We're doing a lot of this, except for Graph, that sets it apart. Yeah, the other thing I wanted to very quickly show, well, why don't you go through the other questions, Matt, and
Okay, we might have one or two more before we announce the AirPods winner. Alex, I'll give you one. I wonder if you know this. I've seen it before. It's a question about embeddings, and I can't find the question now, but I think it was something about like, are these embeddings compatible across different models? And if so, is there a way to do that? Do you know the answer to that, Alex?
Yeah, that's a really great question, actually. So in this demo, we actually used the Vertex AI embedding model. Another embedding model that a lot of you may be familiar with is the OpenAI embedding model. Actually, embeddings are not cross-compatible between different embedding models. So what that means is when you create your embedding database by chunking and embedding and then storing those embeddings, you will need to use the same embedding model at query time to embed your question to get a coherent response, because embedding models are themselves trained on different data sets, public data sets, private data sets. And so yeah, you will need, the short answer is you will need to use the same embedding model to create your embedding database and then also to embed your query, so you get accurate responses when you're doing RAG.
And so if their question is, can single store help with this, is the answer you need to store your embeddings for multiple models? If you want to use multiple models, you should store those multiple embeddings inside single store. Is that the solution?
Yeah, I would personally, I would just recommend sticking with one embedding model. There is some additional performance that you could squeeze out of fine-tuning an embedding model, actually, which potentially a future webinar. But if you were to do that, you would need to use, you'd basically just replace all your vectors with the new embeddings from your custom model, and then you'd be using that custom model also to embed your queries.
Got it. Go ahead, Madhukar.
Yeah, so I wanted to
go ahead.
Yeah, so I wanted to quickly show this because there were a lot of questions around it. So this is Vertex AI, right? And as Alex showed, you can go pick a model, and these are the different models. It tells you what are the different kinds. So embeddings for text and so on, you could choose that. And then think of it as you take a model from the garden and you use as is, or you fine tune it and then deploy it for your instance and then use it. So if I were to just use an existing, let's say, model that they have, then they have something like a playground similar to what ChatGPT has. So for example, this is not fine tunable. So if I click on this, I can just say view code or open prompt design. That's the playground. And when I click on that, this is what I think Alex had shown, is here on the right, you could see the view code. And this is where you get the project ID, right? And you can use this to then make a call to this specific model, but this is not specifically just deployed for you. If you want to deploy your own, then what you would do is you would go here, deploy and use, and you start from here. So you take a managed data set, you train it or fine tune it, not train it. And then once you go through it, it will give you your own endpoint. So you'll be paying for it, but it's private to you, and then you use it. And in that call, in that URL, then you would be using single store with your with that model. Now, coming shortly, we are also building a Vertex AI extension. So you will be able to use single store directly from here as a data source as well. But that's a future thing that's coming. So just stay tuned for that.
Good stuff. We should probably go ahead and announce the AirPods winner. Quick note before I do that, reminder, we have Monday, Beginner's Guide to LangChain. Chat with your multi-model data. I put that RSVP link in the chat. Hopefully I will see you there. And then the winner announcement, today's AirPods goes to Pratik Singh, VP of Software Engineering at Wells Fargo. Congrats, Pratik. Thanks for joining. If that's not you, don't give up. We're going to announce one more AirPods winner by the end of the day for anyone who has tried out today's demo. So keep an eye on your email. We will send out the code notebook as well as the recording to this session. Thanks so much to Alex for an awesome presentation. Thanks, Madhukar, for joining us throughout the Q&A. And thank you to our audience for joining. Have a great rest of your day, everyone.
Thanks, everyone. Thanks, Matt.
Thank you.
Bye-bye.